an unobstructed view of the sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रांजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। उपग्रह को भी
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Deepako Brahmanda Bhandasya, Asayeva Charkarti, Bharvati, Charhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth. The explosive phenomena in sun and the after having filtered by the atmosphere is available for the sustenance of earth. The explosive phenomena in sun and the after having filtered by the atmosphere is available for the sustenance of earth. The explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in sun and this after having filtered explosive phenomena in such points after having filtered explosive phenomena at such points after having filtered explosive phenomena at such points after having
vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer. The Aditya L1 spacecraft carries 7 payloads, electromagnetic, particle and magnetic field detectors. The Aditya L1 spacecraft, first among the 4 L1 spacecraft, payloads visible emission line and matches out the Aditya L1 spacecraft. The prime payload is 7 lines as a reflective coronagraph with a multi-slit spectrogram. This payload L1 spacecraft by payload Laboratory of Electro-Optical Systems, URAO Satellite Center, Space Inertial Systems and Space Application Center. The second payload is designed to measure the solar soft X-ray plug to study solar flares. This payload is developed by URAO Satellite Center. Third payload is the Solar Ultraviolet Imaging Telescope, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Intiuni, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer package for Aditya, in short, PAPA. It is designed understand the solar
Stand by for
winds
the
and
timer.
its composition and
T-minus
perform
35
mass
minutes.
analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center, which will measure the low intensity interplanetary magnetic field in space. A pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन के बारे में जानते प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर सॉफ्ट इसी क्रम में अगला है SOLEX जो कि सूर्य के सोलर लो डिजिटल मैग्नेटोमीटर इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में। यान पूरी तरह सामान्य सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharatwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripati, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the Principal Scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wavebands which are very important for the Earth ionospheric connections like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this, allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology, as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we'll move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the...
So much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the
To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun and the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7, through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. It's not absorbing the light which is coming from the Earth.
Thank you very
The other
much.
PI will also be
And now
explaining
we'll move
about
on
it.
to
So these
Durgesh
holistically
Tripathi,
will give
Dr.
you a lot
Durgesh
of
Tripathi.
information regarding
You are
not
the
only the
PI
sun, but
of
also
the
the
base
heliosphere.
suit
It's not
Doppler.
absorbing the light
That
which
was
is
very
coming from the
interesting.
Earth.
Thank you very
The other
much.
PI will also be
And now
explaining
we'll move
about
on
it.
to Hubble
So
audience.
these
Durgesh, and what are you going to investigate using this?
So good afternoon. My voice is going to mumble by because I'm still in the awe of the launch, and one of the payload is gone there. So
holistically will give you a lot of information regarding
essentially JWST, which is James Webb Telescope, and the
You are
not only
the
the sun,
PI
but
of
also
the base suit.
universe, different objects.
it's not absorbing the light which is coming from the Earth.
How is that
The other
different
PI will
from
also be
others?
explaining
Now we'll
about
move on
it.
to
So
Hubble
these
audience.
One, it is
And what are you
to
going to
look at one
investigate using
particular
this?
object, which is our sun.
Good afternoon. My voice is
And
going to
it's
mumble
also,
by
kept on
because
the
I'm
other
still in
side
the awe of
sun
the launch,
At
and one of the
point,
payload is
whereas
gone there.
James
So
Webb
holistically will give you a lot of information regarding
essentially JWST, which is James Webb Telescope, and the
You are
not
the
only the
PI
sun, but
of
also
the
the
base
sun.
suit.
they also
different
observe in
objects.
ultraviolet.
It's not absorbing the light which is coming from the Earth.
How is that
The other
different
PI will
from
also be
others?
explaining
Now
about
we'll
it.
move on to
So these
One, it is
And what are you going
going
to
to
investigate using
particular
this?
object, which is our sun.
good afternoon. My voice is going to mumble by because I'm
You are
not
the
only the
PI
sun,
of
but
the
also
base
the
suit.
They also observe in
it's not absorbing the light which is coming from the Earth.
How is that
The other
different
PI will
from
also be
others? Now
explaining
we'll
about
move
it.
on to
So these
One, it is
And what are you going to investigate using this?
object, which is our sun.
good afternoon. My voice is going to mumble by because I'm
You are
not
the
only the
PI
sun,
of
but
the
also
base suit.
They also observe in
it's not absorbing the light which is coming from the Earth.
How is that
The other
different
PI will
from
also be
others? Now
explaining
we'll
about
move on
it.
to
So these
oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds and how does it impact?
Thank you. Thank you.
One,
So these
for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have.
And also,
Thank
this
you
sun
very
is
much,
plasma.
sir. And now we
when we are
move on
talking about the
to
heliosphere,
Dr.
actually,
Satish
all our
Thampi.
planets are engulfed in
You are
that.
connected with the payload
No, we have been
PAPA.
studying in decades.
Already the
decades,
plasma
we have been
particles
studying
on the
this.
moon
But
are
what we
analyzed.
lacking actually a
How do you
combination,
analyze
because
plasma
sun is
particles in
giving
the
its energy
sun?
mainly in three forms.
And what is the
The first
importance
one
of
is the
solar
radiation,
winds and how
actually.
these
Hero
For
basically
example,
in the
and
solar system.
also these
But
explosions
look at
which
the
are
mass
happening,
of the
how much
solar
radiation
system,
they are
99%
creating,
of the mass of the
and how
solar
much
system
effect
is
it might
the
have.
diameter. And also,
solar winds and how
Hero basically in the solar system.
Also these
But
explosions
look at
which
the
are
mass
happening,
of the
how much
solar
radiation
system,
they are
99%
creating,
of the mass of the
and how much
solar
effect
system
it
is
might
the
have.
diameter. And also,
solar winds and how
Hero basically in the solar system.
Also these
But
explosions
look
which
at
are
the mass
happening,
of the
how
solar
much
system,
radiation they are
99%
creating,
of the mass of the
and how
solar
much
system
effect
is
it
the
might have.
diameter. And also,
Explosions which are
mass of
happening,
the
how
solar
much
system,
radiation they are
99%
creating,
of the mass of the
and how
solar
much
system
effect
is
it
the
might have.
diameter. And also,
Explosions which are
mass of
happening,
the
how
solar
much
system,
radiation they are
99%
creating,
of the mass of the
and how
solar
much
system
effect
is
it
the
might have.
diameter. And also,
Explosions which are
mass of
happening,
the solar
how
system,
much radiation
99%
they
of
are
the mass of
creating,
the
and how
solar
much
system and also the explosions which are happening in the transmission more than using of the mass spectrometry and also the explosions which are happening in the transmission more than using of the mass spectrometry and also the explosions which are happening in the transmission more than using of the mass spectrometry and also the explosions which are happening in the transmission more than using of the mass spectrometry and also the explosions which are happening in the transmission more than using of the mass spectrometry and also the explosions which are happening in the transmission.
So if you look into that thing, actually, that one actually gives the equal number of electrons. What we call the. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. It gives like in a CME, CAR or this. So that one actually gives the equal number of electrons. What we call now. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. It gives like in a and also how or this the equal number of what we call now. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. And also how the equal number of what we call now. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. So if we know these things, and also how we don't want the mass, but for the ants we are getting the mass. The equal number of what we call now. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. Effect of this. So if we know these things, so in due course, and also how we are in addition to other for the ants, will be able to the equal number of what we call now. So our PAPA is a comprehensive package measuring both ions and the normal routine phenomena. Now all things are so in due course, and also how we are.
Thank you so much for that, sir. And at Nainital, how do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of science?
India has a long tradition of looking at the sun from the ground.
Will
In fact,
supplement
from
Aditya
1973, we have
Can
been
you tell us
observing the
something
sun
about the
for more than
history
100 years. Solar observatory at Udaipur, in the lakeside, and at Nainital. In fact, a small satellite program. And then Professor U.R. Rao suddenly came up, think big, we should go to much longer distance, think big, and then we should go to much longer distance, think big, and then we should go to much longer distance, think big, and then we should go to much longer distance, think big, and then we should go to much longer distance, think big, and then we should go to much longer distance. Very important to have the shorter wavelength coverage from the space. And in addition, very important to have the shorter wavelength coverage from the space. And in addition, very important to have the shorter wavelength coverage from the space. Combination. And since you asked about the question about the, how Aditya in the overall heliophysics research within around Lagrangian 1 point, primarily from NASA and ESA. So I think again this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this, and as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have. And in addition, that a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have. And in addition, that a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have. We have already projected a National. I think this is now high time we have. We have already projected.
Whenever there is an extreme solar event, such as the coronal mass ejection or say a solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were I think this is now high time solar event.
Really
so
going to affect
keep an
our
eye
planets.
on the
That's what we call
surroundings
the
of
space weather.
Earth.
Now,
we
our
need
intention
these
is to
measurements,
understand,
and
first of all,
apart
actually,
from that,
what
observation is
in the
whenever
ambient
there is an
conditions as
extreme
well as
solar
during this
event,
time period,
such
how
as
the
the
solar
coronal
will
mass
behave.
ejection,
And also
or
how
say
this
a solar
coronal mass
magnetic
ejection
storm.
is possible.
Now,
Dr.
these
How actually, what
events
are
are
the different
crucial
what we call
to
the
monitor the
important
solar
one thing is actually
event.
this is actually going to affect
Keep
our
an eye
planet.
on the
That's what we call
surroundings
the
of
space weather.
Earth.
Now, our
We need
intention
these